I wasn't.
Yeah. I'm
Okay, everyone, let's see. So this quiz is due, I believe, Friday night, correct? I'm pretty sure it's Friday night. And the only thing we have left to do is oxidation reduction. So this quiz is Friday, like 11:55. I think it's 11:55 p.m. And then is all Sunday night? Chapter, what's that? The owl for chapter 3?
Yeah.
I'm gonna change that. Did you submit it? Let's not do it tonight. You guys didn't submit, did you?
I did.
Yeah. We was due. I've got all now, yeah, because I originally we were going to have the test on Friday, so I might back that off a little bit. I'll send it.
That would be nice.
How many times can you submit an hour? Can you submit more than once an hour?
I think so. I'm not sure.
Not sure. Just resubmit your same email, yeah. Okay. Yeah, we're gonna finish up today and then I'll give you what's gonna be on the test. Oh, actually, I did a little bit of outline this morning for that. Is there any questions on this? We haven't covered oxidation reduction. But we're gonna do that today, we'll be done. And that's gonna allow you to answer pretty much all of these then. So let's do that. I gotta get that roll sheet going around. So we'll do oxidation reduction. So let's do that in the learning guide. And then at the end, we'll talk about the tests. So we should be right here. So we know that the Earth's atmosphere contains about 20%, maybe somebody would say 21% molecular oxygen. And of course, a chemically reactive gas that plays an essential role in the metabolism of aerobic organisms in many environmental processes that shape the world. The term oxidation was originally used to describe the chemical reactions involving oxygen. But its meaning has evolved to refer to a broad and important reaction class known as oxidation reduction, and people just say redox. Now, not only is O2 in the air as a gas, we know O2 is in the water as aqueous. Right, so keeping our fish alive is O2 gas, aqueous within water, otherwise just regular O2 that's in the air. So oxidation reduction is not too complicated. Here's an example. If you have oxidation reduction reactions, the oxidation number will change on one of the reactants or products from one side to the other. So this one right here, I'm going to zoom in on this. And here, anything by itself does not have a charge. So this is 0. This is sodium metal. It is uncombined. This is chlorine gas, uncombined. All the protons and electrons match. Now, let's go to the next page for the definitions, and then I'm going to come back. So, oxidation is the loss of electrons. If you lose electrons, your oxidation number is going to go up. You have the same number of protons. If you lose electrons, your oxidation number is going to go up and it's going to become more positive. But the easy one to remember is reduction. So reduction gains electrons. It's going to be a decrease in oxidation number, or it becomes more negative. This word right here, reduce or reduction, becomes more negative. Pick that one out first. Then you know oxidation is the opposite. It becomes more positive. Then the reducing agent is the species that is oxidized, and the oxidizing agent is the species that is reduced. They're just the opposite. So let's go back to the first page. Pick out the one that is becoming more negative. So over here on the product side, sodium is +1 and chloride is -1. So which one is becoming more negative? Going from 0 to -1, this is reduction. And then the one that's becoming more positive. Why did I draw that wrong? Jeepers. How about we go to here, right? This is reduction. From 0 to -1. This is my reduction. And then becoming more positive is oxidation. This is oxidation. You know what? I'm going to clean that up down here because it bugs me. Reduction, becoming more negative. That means, according to the language, if this is undergoing reduction, this is the oxidizing agent. And then sodium is becoming more positive. So that is undergoing oxidation. So sodium is the reducing agent. Right? It's just opposite. Whatever's undergoing reduction is the oxidizing agent, and whatever's undergoing oxidation is the reducing agent. Remember, anything by itself should not have a charge on either side. On either side. So if you have an oxidation reduction reaction, it is going to change oxidation state or charge from reactant to product or product to reactant. How are you looking at it? Okay. And if you have something by itself on one side, uncombined and a compound on the other side, or vice versa, it's oxidation reduction. So in order to figure out this, let's review oxidation numbers. Let's review oxidation numbers. So what is the oxidation number of sulfur in the following compounds? So hydrogen is always +1. So the oxidation number of sulfur here is -2, right? This would be sulfide. What is the oxidation number of sulfur here? This would be chloride, -1, and there's 2 of them, so that's a -2. Here we got a +2 sulfur. So this is in the compound sodium sulfite. We know oxide's always -2. So that gives us -6. Sodium is always +1. So we got +2. What do we got for the sulfur there? +4, right? This is my +4 sulfur. SO4. This would be -2. That's a -8. +8 sulfur. And over here, -2 on oxides. You can always count -2 for the oxides, +1 for the hydrogens. So we have -8. -8 and +2. So if we have -8 and +2, we've got a +6 here. Okay, let's look at some examples down here. Right away, looking at A, you know you have oxidation reduction just looking at it. How do you know that? Because magnesium here by itself is going to be 0. It's in a compound over here, so it has to have a charge. And likewise, nickel here by itself is 0, and it's in a compound over here, it has to have a charge. So let's figure out the exact charge. Remember, to figure out the charge of positive ions, you know what the negative is. You know what the negative is. So we know right here, chloride's -1. And for magnesium, there's only one charge it can be, and that's +2. Chloride here, -1. Nickel can have more than one charge, but since chloride is -1 and there's 2, we have nickel 2 here, right? So now let's identify what we have. Which one's reduction? Which one's becoming more negative? That's the one I always look at first. And the one becoming more negative is nickel, right? +2 to 0. So this is reduction. And the one that's becoming more positive is oxidation. Then that would be magnesium, right? Oxidation. I'm going to skip B for now. Let's do C. Is C oxidation reduction? Well, actually, let's go back to B. We'll figure it out a little bit here. Just identify, is B oxidation reduction? For sure, right? For sure. Why do you know that? Because oxygen sitting here by itself has to be 0. And over here, oxygen here, -2 and -2. So for sure it's oxidation reduction. And if we have time, we'll come back, but you just want to be able to identify that as oxidation reduction. In letter C, do we have oxidation reduction? For sure, yes, because we have zinc sitting here by itself 0, and over here it's in a compound. So here it should be +2. And you got hydrogen sitting here by itself, it has to be 0. And here in the compound, it should be +1. So which one of these is undergoing reduction? The hydrogen here. So we are going from +1 to 0. And then zinc is going from 0 to +2. So that is my oxidation. In letter D, sulfur compounds can be wicked. So let's figure out what we've got here. Do we have oxidation reduction? Yes. How do you know that? Looking at it, iodine by itself right here is 0. And over here it is -1. So you already know that's reduction. Now let's figure out the rest. And this one's kind of ugly. Not kind of ugly, it's brutally ugly, to tell you the truth, brutally ugly. Oxides here in a compound are -2 and -2. Potassium is always +1 in the compound, so +1 and +1. But here's the sulfur. So if we total this up here, -6 for 3 oxides, -6 for 3 oxides, +2 for 2 potassiums. All right, 2 potassiums +2. We need a +4 to get 0, correct? And a +4 with 2 sulfurs means each of them is a +2. So we got +2 sulfur there. What do we have over here? We have -12, +2. We need a +10, yes? What is 10 divided by 4? .5, right? What the heck is going on there? 2.5. Well, over here, if we did this, we've got 4 sulfurs. We got to get a 10 total, right? And sulfur can be +2, +2, +2, and one of these must be a +4. That's the only possible way. One of those in there, 3 of them are a +2, one of them must be, one of those must be a +4. So if you're doing a question like this, I think it does do a 2.5, but realize that's how you get it. +2, +2, +2, one of them is a +4. But let's identify then, what do we got here? We've got reduction here. And we have oxidation on the sulfur. Becoming more positive, right? In letter E, do we have oxidation reduction? For sure we do, right? Because we got copper sitting here by itself, and we know that this copper right here is 0. That's a chunk of copper wire. It's a copper penny. We're putting it in HNO3. What is the name of HNO3? Hydrogen nitrate or nitric acid? Hydrogen nitrate or nitric acid. Over here, if this is nitrate, what's the charge of nitrate? -1. So copper's a +2 because we've got 2 nitrates, right? So we already know that that's what? 0 to +2 is? That's my oxidation, right? That's undergoing oxidation. That means this is my reducing agent. Okay, where is being reduced here then if that's being oxidized? Let's see what we got here. More than likely, it's going to be nitrogen here. What's my nitrogen charge right here? HNO3, what's the charge of my nitrogen there? plus 5, right? -6 plus 1, that's a plus 5 nitrogen. And what's my nitrogen right here? Plus 2. So for sure that is undergoing reduction. So this is my reduction. Now, some books kind of do this differently. This whole thing then, it's the whole thing. So nitrogen is undergoing reduction. HNO3 would be my what? This would be my oxidizing agent. In F, we already have it as split up aqueous ions. So in F, what do we got here? Something becoming more positive, iron. So that right here is oxidation, right? It's not getting more negative. So that's oxidation. And manganese in right here then. What's charged as manganese? +7, right? Is this, it has to equal -1. It has to equal -1, that's 0. This is an ion. So again, when you do lab this week, if you put in MnO4 with no charge, you're assuming that you have an MnO4 compound, which means you'd have a +8 manganese, which does not exist. So make sure when you're doing lab, you have to put all of the charges in. So here we have a +7. And over here we have a +2 for sure reduction. Okay. So that was section, what was that in the book? 3.8, must have been 3.8. Yeah, 3.8 is on oxidation reduction. And the last thing is basically just doing types of reactions here. 3.9 is types of reactions. So how do you know a reaction takes place? Or some types of reactions, first of all. Combustion reacts with oxygen. Typically, you're going to be burning like a CXHY plus O2. What do you always get if you burn butane from a cigarette lighter, propane from a propane tank, from a barbecue cylinder? You'll always get carbon dioxide plus water. Always, always, always. So this combustion reaction is oxidation reduction, right? Because this is always 0 for oxygen. And over here, -2. And a combustion reaction should produce heat and light. And again, carbon dioxide and water. If there is lack of oxygen, you get, instead of carbon dioxide, carbon monoxide. So when you see roof vents, if those roof vents or side vents in houses go to a furnace, which they do, and if mud wasp and stuff have gotten in there over the summer, when people start up their furnaces for the winter, the furnace gets deprived of oxygen, and people then, instead of producing carbon dioxide, which is harmless, you get carbon monoxide. Otherwise, if you have a combination reaction, you've got 2 things on the reactant side, 1 on the product side. And the opposite of that would be decomposition, 1 reactant, 2 or more products. Exchange reaction, metathesis. I would call this double replacement. So A kicks out C. C, you're just going to replace them. So a double replacement, your textbook uses the old metathesis term. How do you know a reaction takes place? You're going to see gas bubbles, there's going to be a temperature change, color change, or a precipitate, insoluble species form. Now, the other one is single replacement. I don't know why the book doesn't cover single replacement. And single replacement is simply this single element here, which can form a positive charge and replace something else that has a positive charge. And when hydrogen gets kicked off by itself, this is hydrogen as a compound, here it's 0. This for sure is oxidation reduction. 0. For single replacement, you just simply see a single element, whether it's a gas, a non-metal such as chlorine, fluorine, or a metal. Kicking out another one. So those are single replacement is oxidation reduction, or redox is just what for short. So let's identify these down here. What type of reaction, first of all, is it? Synthesis, decomposition, single replacement, double replacement. What type of reaction is this?
A is decomposition.
This for sure, decomposition. You have one reactant and two products. So decomposition. Is there oxidation reduction going on here? What's the charge of zinc? Always, always, always when it's in a compound? +2, right? And it's in a compound here is +2. It's in a compound here as +2. Oxide -2. Oxide to -2 here. -2. The one that can change is carbon. What's my carbon charge here? +4. And my carbon charge over here is +4. So that is not redox. How about for letter B? What type of reaction, first of all? What type of reaction? You can page back. So the term here is combination, or a better one is synthesis. What did I use on the quiz? Did I use the term synthesis or combination? I used synthesis. I use synthesis, so let's change that on the previous page. It's just on the previous page, we can just add this. I use the term synthesis. And is this oxidation reduction? For sure it is, right? You know for sure it is. You've got Ga with gallium sitting here by itself. You've got bromine sitting here by itself. Those are 0. And in the compound, bromide is -1 and gallium would be a +3, right? Okay, identify, we have provided name for those identified as re-identified, what is oxidized, what is reduced? Okay. So the reduction is here, becoming more negative and becoming more positive. Oh, C, I can't believe I put C in there. Oh. Of course, it's chemistry. There's got to be a freakish exemption, right? Chemistry's always got to have some kind of freak show going on. This is the freak show. Now, what type of reaction is this, first of all? This right here is decomposition. Is it oxidation reduction? Oh yeah, for sure, right? Because you've got oxygen here by itself at 0. Now, what is the charge? We know oxide here is -2. Hydrogen 0 is +1, but this is the freak. This is not water. What is this compound? What is this compound? H2O2. This is hydrogen peroxide, right? This is hydrogen peroxide. And what do you have for hydrogen peroxide? You have this. +1, +1, -1, -1, right? Peroxide is O2 -2. So each oxide is -1 within peroxide. Again, peroxide looks like this. O2, 2- or -2. So what we have going on there then is becoming more negative is reduction. Right there, right? From -1 to -2, that's reduction. And then becoming more positive from -1 to 0 becomes more positive, then one of those is undergoing oxidation. D, what do we have? What type of reaction? Double replacement or metathesis, right? Double replacement or metathesis. So remember, we drew those beakers out, right? And we said that the positive ion in one beaker can get together with the negative ion of another beaker. So we just switch them. And you're going to do some of this in lab. And then you're going to look at the solubility chart in lab to see if you get a solid. And if you get a solid, this is a precipitate, or it may be called a precipitation reaction, a precipitate solid. But all the charges in this stay exactly the same. So we could go +1, -1, +2, -2. This is a +6. So if you figure it all out, that is not redox. And that is typical. Okay, you should be able to finish everything up for the quiz. Let's talk about the test. So the test. There are 4 versions of the test. They'll be on 4 different colored pieces of paper. The test is 38 questions. And let me show you this, and then you can probably just take a picture of the screen because I made a thing this morning here. Let me stop share. Let me share a different screen. Okay. So this will be page 1 of your test. So here's, and I redid this a little bit. If somebody doesn't put their name on the test, if I run your Scantron through as test A versus test B, something like that, and you get like a 12% when you should have got a 92%, all I got to do is come back and there's going to be a picture of this page that you're going to submit to Canvas. Now, I'm not going to grade your test until this is in. So what you're going to do on page 1, when you come in for your test, and I'm not sure how I'm going to do it, but you're not going to have the same color test next to you, right? There's 4 different colored sheets of paper. There's 4 different versions of the test. It's all mixed up then. There's going to be a Scantron sheet. There's 38 questions, but you are going to put your ID on this page. You are going to write, the exam number is going to be written in here. Your seat, wherever you're sitting, put that in there. Take your phone, print your name here, and you can read it right now. I'll give you a few seconds. Read that. Okay, so this will be page 1, test 1, upload. And again, all I'm doing it is in case something gets messed up, and I've done it. Last semester, I had 120 students. We only got 90 this time. And it's just so easy. I could just go to that picture. So you don't have to, previously, I had people upload it before they even started their test. You take a picture and then upload the picture later after the test. But you're not going to get a test score until that picture's in. Okay. All right. So then this will be on the test. So you can use a periodic table, and then this is on the test. Okay. So the periodic table in this, your periodic table has your charges and everything, right? So, but you still need to know a sulfate. I went through it, sulfates, nitrates, phosphates, some of those. So then I just did this morning. I had to get the test in. It is stressful trying to make a fair test. Now, last semester, the students had 1 hour and 15 minutes, and there was 75 questions. We have 50 minutes, and there's 38 questions. So it's half. So if you want to take a picture of this, this is what I drew. This is what I came up with this morning. And let's probably better than writing it all down. And in the future, I'd probably type it all out. Oops, I got to share this screen, don't I? I'm going to reshare. Hold on a second. There we go. Oops. I don't want to do that. There we go. Does it work to take a picture of that?
Yeah.
It looks pretty good. So, and then I have students come without a calculator. So I put on there. So you get to use your periodic table. You know that solubility table is on there. Bring your ID. You're going to send it on there, take a picture, do your test, right? And it's going to be a Scantron, so you need a pencil. Bring 2 calculators. Steal your roommate's calculator. Find another calculator. Bring extra batteries. Check your batteries. I am appalled at how many batteries still leak, that we haven't perfected that in the last 75 years. I opened up the cordless keyboard yesterday. the battery's leaking. So if the batteries are leaked in your calculator, use a Q-tip with some baking soda. And that'll neutralize that out, but check your batteries in your calculator. Have extra batteries for your calculator. Steal your roommate's calculator. Come with 2 calculators. Now, that kind of summarizes it. So you know it's got 38 questions. Obviously, you know if you're writing the formula of a compound, that's a 5-second question. When you're writing out a complete ionic reaction, it's going to take you a while to write that out. So, like 38 questions, all multiple choice. 4 different versions of the test. Any questions? So chapter 4 is ready to roll. We'll do chapter 4 Friday, right? So you can print it out. The version that is loaded then in Canvas should be good. Now, the quiz is due Friday night. I didn't change the owl. They had owl due tonight, right? Okay. I still have a couple people. I'm gonna put zeros in. I haven't not submitted one owl time. I'm just gonna put zeros in for those. And then I will change the deadline for owl then to match the quiz to Friday night. Okay? We'll match. So I'll do that after class. I'll send the recording. All right. Have a great day, you guys.